So moving on to part B. Part B is going to be a BNF question. So it says to write a short string of fewer than 10 characters that matches the BNF grammar below, but is guaranteed to cause an error when evaluated by Scheme, regardless of how many symbols such as F are defined in the environment. Okay, so let's just look at what the BNF structure is. So we start with an expression. An expression can be either an integer or something of this shape, which is basically parentheses, operator, and then as many expressions as you want. So xp1, xp2, xp3, dot, dot, dot. But we know that there has to be at least expression 1. And then it's defining what an operator is. An operator is either a procedure or another expression itself. And then a procedure is going to be just a symbol f that's defined in the environment. So we're going to assume that all the symbols are defined. So we're going to have cons, we're going to have if, we're going to have whatever scheme procedures we have. Okay, so now with this structure in mind, let's think about what would cause an error when evaluated by Scheme. Well, there's a couple of Scheme rules that would come into mind. For example, like all the parentheses have to be matched. But this is probably going to be a little bit hard to exploit because it seems like every expression is defined to have these open and closed parentheses. So probably not that. How about the rule that all Scheme, everything that you evaluate in Scheme has to start with an operator, right? Or like a procedure. So for example, if you had a Scheme expression like plus 1, 2, well, this is going to evaluate fine. It's going to equal 3. But if you had something like 1, 1, 2, well, Scheme doesn't really know what to do with that, right? You don't know, are you adding all of the elements? Are you subtracting? Like, there's no procedure that you've defined. So this just happens whenever you have like an integer literal as your operator. So let's see, does this BNF structure let us exploit that? Well, I think it will, because you start with an expression, right? An expression can either be an integer or another operator, and then one or more expressions. So let's first go into this option, right? So this is going to be our first kind of match. So we're going to have our parentheses. I'll just erase this for now. Okay, so we're going to have our parentheses. We're going to have our operator. And let's just say that we have one expression. We can have more than one, but let's just say for the purpose of this, we have one. So we're going to have to match or define what operator is and what expression is. So operator can either be a procedure or another expression. So if it's a procedure, well, then we're not going to have an error because f is always going to be defined. But what if it's another expression? Well, if it's another expression, then we have two expressions here. And we know expressions can either be integers or these another like nested parentheses operator expression. So what if we chose these to be integers? Well, if they were both integers, and this is also an int, then we kind of get this structure where we have an integer literal as our operator, which is going to be an error because you can't evaluate 1 and 1. So that's exactly an example that you might write out. So you could write just 1 and 1, and that would be something that is matched by this BNF grammar, but would cause an error if evaluated by Scheme.